Good morning, dear students. So today we are going to discuss one of the important topic, that is the method of preparation of carboxylic acids. So how to prepare the carboxylic acids? First, we will take the well-known reaction. We have already discussed this reaction. That is by oxidation of primary alcohols or aldehydes in presence of normal oxidizing agent K2Cr2O7 or potassium permanganate. We know that when the alcohols were treating with these reagents, the alcohols gets oxidation, which results in the formation of aldehydes, which further gets oxidation, results in the formation of carboxylic acids. So here the reaction does not stop here. The when the with the formation of aldehydes, it further gets oxidized, as a result of which the carboxylic acids were formed. Clear? So this reaction we have already discussed, but in case of in order to form the aldehyde, here in order to stop this reaction, we have used the special catalyst. We have used a special oxidizing agents here. Clear? So you must remember that. So for in order to prepare the carboxylic acid, you may use these potassium dichromate or potassium permanganate, acidic or alkaline, potassium dichromate or potassium permanganate solutions. Clear? So in order to prepare the carboxylic acids, you may primary alcohols are treated with these reagents. The carboxylic acids can be prepared. Now you may take the example here. It is ethyl alcohol. It results in the formation of acetaldehyde, which further gets oxidized into acetic acid. So here the reaction does not stop here. It further undergoes oxidation, resulting in the formation of acetic acid. We may also write the reaction like this. For example, it may RCH2OH, primary alcohol, under oxidation, in presence of oxidation gives RCOH. Clear? The reaction may be also written as like this, because the primary alcohols and in presence of these reagents form the final product carboxylic acid. Clear? So here is an example how the primary alcohols undergoes oxidation to form the carboxylic acids. Second, by oxidation of aldehydes by Toulon's reagent. This these reactions have already discussed in. You may remember the silver mirror test, when this aldehydes were used as a reducing agent in order to reduce the Toulon's reagent. Clear? You when this acts as a reducing agent, it means that it gets oxidized. So the oxidation of aldehyde here takes place by means of what? By means of Toulon's reagent, resulting in the formation of acetic acid, and here the silver is formed, which gets reduced and it gets decomposed on the walls of the test tube, which looks like a mirror. That's like it is called as a mirror test. There's a silver mirror test. The silver gets deposited in the walls of the test tube. The reaction is a well-known reaction used to identify the aldehydes and ketones. Clear? So you may also write this reaction for the preparation of carboxylic acid, or you may also write another reaction as filling, by treating the aldehydes with a filling solution. So the aldehydes, where these aldehydes acts as a good reducing agent, because they itself gets oxidized. Its oxidation gets very fast, as a result of which they act as a good reducing agent in order to reduce this filling solution. So here also the carboxylic acids can be prepared by using this filling solution. So it may be oxidized, oxidation of aldehyde may takes place, यानी कि आप ऑक्सीडेशन ऑफ एल्डिहाइड कर सकते हो यहाँ पर. क्लियर? क्योंकि इस एल्डिहाइड की वजह से फिलिंग सोल्यूशन रिड्यूस हो गया था. तो अब इट मीन्स दैट इसकी ऑक्सीडेशन हो गई है. क्लियर? इट मीन्स दैट फिलिंग सोल्यूशन विल हेल्प अस टू oxidize this aldehyde. Clear? Because aldehyde gets rapidly oxidized in filling solution. So here the same, that is acetic acid, gets oxidized in presence of what is called as a Toulon's reagent to form the acetic acid. Silver and ammonia is formed. So one of the well-known reactions, we have already discussed it. Second is by oxidation of secondary alcohols and ketones. You must remember that where we're discussing about the oxidation of alcohols or oxidation of ketones, we had discussed that oxidation does not occur under normal conditions. So, or under normal conditions, this ketones or secondary alcohols resist the oxidation, further oxidation. Clear? So, in order to do so, in order to oxidize these alcohol or ketones, we may use a strong oxidizing agent. For example, concentrated HNO3 is used here. So here you must write down that here the reagent is used actually concentrated HNO3. You may add here that concentrated nitric acid is used here, as a result of which this isopropyl alcohol, it gets first oxidized into result in the formation of ketone, which under further oxidation results in the formation of acetic acid, and carbon dioxide and water side products are formed. So here is the main product which is formed, that is acetic acid. Clear? So it is a by oxidation of secondary alcohol and ketone. But you must remember right here that in presence of concentrated HNO3. Clear? It's in presence of concentrated nitric acid. Clear? Similarly, the carboxylic acids are also prepared by hydrolysis of esters. So hydrolysis of esters takes place. You just take the ester here example. For example, we have taken the ester in presence of water. Actually, what happens here that this OH part will attack here, and it results in the formation of what you will see here, that product will be like that, or CO, the bond gets shifted here, get negative charge on this oxygen, and you will see here OH is bonded to that this carbon, and this oxygen contains or also. Clear? And this hydrogen will be accepted by this oxygen, and result in the formation of, there is a cleavage of this bond, and alcohols are formed. And carboxylic acid, here the bond shifting takes place from oxygen to carbon. Carbon double bond forms. So here the product will be acetic acid and alcohol. Clear? So you just remember OH, here this cleavage OH combines with this carbon, and hydrogen combines with this OR. This is the formation of alcohol and carboxylic acid. Similarly, you may take the, for example, ethyl acetate. Here it's also ester in presence of water. So here the two parts, one part of OH negative will combine with this carbon to form carboxylic acid. Clear? And second part C2H2O combines with hydrogen to form the ethyl alcohol. Clear? This is how the formation of acetic acid and ethyl alcohol is formed. Although the mechanism of the reaction is different, but you don't have to write the mechanism, just remember the reaction. Clear? So this is how you can remember the reaction. Similarly you may take the reaction, another reactant here, that is what is called as a ethyl benzoate. In presence of water, here same thing occur, which combines with this, and this comes in the formation of in the final product as ethanol, and here the formation of main product, that is benzoic acid, is formed from this ethyl benzoate. Clear? Similarly, we can also prepare the carboxylic acid by the hydrolysis of cyanides or nitriles. Clear? Here by hydrolysis of cyanides or nitriles. So for here we have taken the alkyl cyanides. Clear? So actually what happens here that in presence of water, so there actually actual mechanism of the reaction is somehow different, but actually here the water, you know that in case of water, we have hydrogen, two hydrogen and oxygen. So two hydrogens will combine with this nitrogen to form the ammonia. Clear? And this oxygen will combine with this carbon to form carbon double bond oxygen. So as you see here, the product formed here is first amide, which further in presence of H3O 2, it results in the formation of carboxylic acid and ammonia. Okay? So if you want to learn the mechanism of the reaction, I will also show you. So here we have taken the example here, methyl cyanide in presence of water, it gives CH double bond O, and this is amide, and further further with H3O positive with some heat, it gives carboxylic acid, it gives CH3. Actually this is CH3COH. So actually here it is CH3COH, that is acetic acid and ammonia is formed. Clear? So actually the reaction mechanism. So actually what happens here that if you want to see the mechanism of the reaction, for in the first step, what happens that we don't have the enough space to write the mechanism here. Actually for triple bond N, clear, in presence of H positive, it gives, or this hydrogen will combine with nitrogen, it forms and there actually these pi bonds are broken here, and this here happens actually here, and this abstract this hydrogen here. Clear? So I will see here first what happens. So actually at it happens, this pi bond gets break, and this attract to this H positive ion, which is the formation of carbocation here first. Here is carbocation, positive charge on carbon, and double bond with NH. Clear? And in this further in presence of water, it gives, and this now water molecule will get attached to this carbon, that is carbocation. It attacks at the carbocation. The product will be like this, or COH2. Sorry, there it is, we have not enough space here, to NH, and further in presence of, if we know that now this oxygen gets positive charge here, so in order to stabilize this, there it loses one hydrogen. So product will be like this, like we say we will write in the second step. Must write this first. In second step we have seen that it forms RCOH2 double bond NH. Clear? So it loses one hydrogen. Now it forms OH. Clear? OH. Similarly, in it further undergoes rearrangement. Rearrangement in sense hydrogen combines with this hydrogen, and this double bond gets shifted here, and it abstracts this hydrogen to form this, and there is the formation of double bond. It forms here RC double bond O NH2. This is called as amide. So in further in presence of H positive, it gives RC or C double bond O, and it gives carboxylic acid plus ammonia is formed. So actually the reaction mechanism is somehow different, but you only remember the reactions here. Clear? So similarly we will take the for second reaction. that is by oxidation of arenes in presence of acidic KMnO4 or K2Cr2O7. So here we have taken the reactant set toluene in presence of oxidizing agents. For example, potassium dichromate or potassium KMnO4, it gives benzoic acid and water is formed. Clear? Similarly, you may take the ethyl benzene, oxidation gives benzoic acid, and here carbon dioxide and water are side products. Clear? So from toluene you may form the toluene undergoes oxidation, it forms the benzoic acid, and ethyl benzene also under oxidation gives benzoic acid. So it is a preparation from the oxidation of arenes in presence of acidified KMnO4 or K2Cr2O7. Clear? So in the presence of acidified K2 potassium dichromate or KMnO4, these aromatic compounds undergoes oxidation to form the benzoic acid. Clear? Aromatic benzoic acid. Clear? So this is toluene, it forms the benzoic acid. Similarly, the compound here is ethyl benzene, under oxidation it forms benzoic acid. Clear? Similarly, we take another reaction. So here the carboxylic acid can be prepared by the carboxylation of alkenes. This reaction is called as Koch reaction. Clear? So here the alkenes and carbon monoxide, alkene and carbon monoxide are heated with sulfuric acid or phosphoric acid. So this is heated alkene and carbon monoxide heated with sulfuric acid. Fumes of alkene and carbon monoxide are heated with sulfuric acid or H3PO4 and phosphoric acid. The reaction is here we have taken the reactants at alkene. By alkene in presence of this carbon monoxide and steam, so it is steam in presence of water, in carbon dioxide and H2 alkene presence of water, uh, in presence of concentrated sulfuric acid, it gives propionic acid. Clear? So from the carboxylation means addition of here, actually carbon monoxide gets added here, that's why it's called as a carboxylation. Clear? So by carboxylation of ethene in presence of actually the carbon monoxide and ethene are passed through the steam in presence of H2SO4, it gives the propionic acid. Similarly, by action of nitrous acid, so by action of nitrous acid, amides first in acidic amide. So actually what happens here, that actually nitrous acid actually is prepared from this sodium nitride when treated with hydrochloric acid. So here the product will be this chlorine will combines with Na, it gives sodium chloride, and the remaining product remains hydrogen combines with NO2, it gives HNO2. This is called as a nitrous acid. This takes place in the reaction mixture, and this nitrous acid is also formed during the reaction when the reaction takes place. So here we have taken the acid amide. When treated with this nitrous acid, it gives acetic acid and nitrogen and water is formed. This reaction we have already discussed the mechanism of the reaction in the previous videos, so you may check that. So these were some methods of preparation of carboxylic acids. So here we had take acetamide. When treated with nitrous acid, it gives acetic acid, and here the nitrogen gas is released and water is also formed. So this was all about the preparation of carboxylic acids. Hope you understand.